Telomere Pharmaceuticals doing some interesting groundbreaking study into aging. And with me to explain exactly what's going on here, Dr. Chris Chapman, co-founder, chairman, and CEO of Tello Pharma. So great to have you here. And let's just start with the story. Lay the groundwork about the company. What is it you're doing at Tello?
Well, it's very exciting, and we have revolutionary changes in science. And I think that the Nobel Prize was given in 2009 for discovering telomeres. Okay, but since then there's not been a big breakthrough, and what we've done is we've discovered a drug that actually stimulates the telomeres so they're elongated. Now, you have telomeres, you have chromosomes. The chromosomes continue to duplicate, and you have telomeres on top of it. I'll just give you an example.
Okay.
So this is the shoestring, and if you take off the shoestring, your shoes will come off. Just like on the chromosome, the tip of it is a telomere. This is the telomere on the tip,
yes.
And this is the chromosome.
Okay.
Every time the chromosome divides, the telomere shortens. When it shortens too much, the cells die, you age. We've discovered a drug that stimulates the telomerase and elongate the telomeres so you won't age.
Okay.
Okay.
So many questions.
Yes.
So, like I was telling you, I remember reading about telomeres during COVID because there was some research done that long telomeres helped you resist the disease or something.
Right.
But they also are connected to aging.
Absolutely.
Yeah. And so tell me about this drug. Is it a pill? Is it a shot? I mean, what is this treatment?
A telomere is a small molecule. It's taken by mouth.
Okay. Okay. And that's what you are currently in clinical studies with, right?
Well, we're in preclinical studies with it now.
And it has shown promise in mice?
Well, absolutely. And so you understand what a telomere does and what a chromosome does is, this is your telomere again, the cap, it protects the chromosome. And so when they won the Nobel Prize, they discovered there was an enzyme called telomerase. And we have discovered the first time in 15 years a drug that stimulates telomerase to elongate your telomeres. And why this is so important is, I'll give you a case that was done in New England Journal of Medicine back in 2002, and this man had a heart attack. They took his heart and put it into a female. Okay, then they increased the blood flow into the female. Now, when they put his heart into the female, his heart was pumping at 55%, which is pretty good. They put it into the female, and then at first the heartbeat was 33% of what it should have been. After 6 weeks, it was 55%. And so what they did is they went back and did a biopsy of the heart that was a man's heart in the female body, and they found out that her stem cells actually restored his heart, or repaired his heart. Okay, so what that means is the man had short telomeres. He had no chromosomes, so he could not protect himself. And so what happened was the lady, she had long telomeres, and so she increased her stem cell population, which restored his heart. That's why the telomere is so important. The length of the telomere is so important.
Amazing. And you mentioned the Nobel Prize was awarded for discovering telomeres.
It. Okay.
Okay, so you're doing this important work with them, and it has shown, as you mentioned, some signs of promise so far, right?
Absolutely.
In mice. Okay.
Yeah.
Tell me about that study.
So I actually dosed 10 mice. Okay, so what I did is I gave them telomere in their drinking water, and I would take the mouse, and I would follow the mouse from day 1 to day 10. In exactly 10 days from the time the mouse started drinking the water, they would convert from let's say they were equivalent of a 70-year-old man to like a 35-year-old man.
What?
Okay, I've done it 10 times, Jane, 10 times. And it's so good that I could actually give the mouse a drug holiday. I mean, I would stop it, they would go back to being old.
Okay.
I've done it with one mouse, I called him Brad Pitt. Okay.
It's like Benjamin Button.
Because it looks good, but yeah,
right.
okay. Yeah, so it's real. So in that discovery, I could tell that now I know that I can take a mouse and reverse the age of a mouse. And so the next step was, I'm now running 2 clinical trials in dog studies in Kansas City. One is a safety study to see if I can reverse the age of the dog. The second one is a osteoarthritis study. It's an age-related disease. And another thing is when your telomere is shortened, you get age-related diseases. So I can show you that I can take telomere 1 and reverse osteoarthritis in a dog. And those 2 studies are running right now in Kansas City.
Okay, so they're going right now. So then what is next after this?
After this, so when I'm doing a tox program. So I'm setting up to have an IND for humans in first quarter 2025 and an animal IND for canines at the same time.
Okay.
So the data that I'm using for the dog study, I could use that for a human IND for osteoarthritis and an animal IND for osteoarthritis.
It's mind-blowing when you think of how big this could be. I mean, in terms of not just vanity, and we all want to be younger,
right.
but in terms of disease, arthritis, and all of the things that come with aging, heart disease,
Right.
and things like that. So, I mean, have you thought about like what the implications could be for humanity?
Oh, absolutely. I mean, we thought about it, and we put together a team at Georgetown University group, and it's for ethics, it's for economics, and it's for determining what's going to happen, because this is going to be so powerful, such a revolutionary change, that every country in the world want to use this product because they could actually stop the aging process. When you stop the aging process, you stop age-related diseases.
Yeah.
Okay.
What are some other implications of this? I mean, you mentioned economics, I
Right.
mean, Alzheimer's, and thinking about.
All types of age-related diseases.
Yeah.
Alzheimer's is one, Parkinson's disease, all of them. Now, I'm going to tell you about another study that was done at Stanford, and they published this data in 2020. And the reason why telomeres are so important is they had 18 patients that had a stroke. For 6 years, they had no recovery. Okay, so what they did is they harvested their stem cells from their bone marrow, and then they grew them in a culture, and they added telomerase to it. Telomerase is the one that won a Nobel Prize. Telomerase is the one that I can modulate with my compound.
Okay.
They put it back into the brain with the telomerase and grew the stem cells, increased the stem cell population, and then after 6 weeks, 7 of the 18 had the normal function back. Okay.
So what's next then? What would be a timeline? So you mentioned the possible human studies next year, right?
Absolutely.
And then, then what happens next through the FDA? And when might this actually be something that a doctor would prescribe?
Oh, I think so. I think that everyone will want to have elongated telomeres. And so the plan is by the first quarter of 2025, I should have an IND open to start the phase 1 clinical studies.
Okay.
And then after that, we'll do phase 2, and then hopefully the FDA will say, okay, you're doing very well, maybe some type of abbreviated approval or a long-term phase 2 or phase 3 study.
Okay.
But I told you about the 2 dog studies that are going on in Kansas City. I'll tell you about another dog study.
Okay.
So we got a call from a friend in Sarasota who had a dog who had cancer. He had metastatic carcinoma of the spleen. Okay, so he was going in for surgery, the dog was, and he had coded. In other words, he stopped breathing, had a cardiac arrest. He went into surgery, had cardiac arrest during the surgery. Okay, came out of the surgery, had 2 more cardiac arrests. And then they got the spleen out, and then they told the owner, take the dog home, put him in hospital, he's not gonna make it. 2 weeks after it happened, then the cancer spread it to the lungs and to the heart. So 2 weeks after they told him to take the dog home, she took it back to the emergency room twice, and 3 times they said, take the dog home, put him in hospice. They contacted my company and said, can we get compassionate use? We stepped in 2.5 weeks ago, gave the dog telomere 1, and now the cancer's gone, no metastasis, and the dog is up and running, energetic, like his 4-year-old, is a 12-year-old greyhound, is almost 5 or 6 now.
Yeah.
Okay.
Huh. Unbelievable.
Unbelievable.
So,
Well, I'm sorry, it's a German Shepherd.
a German Shepherd.
Right.
Now, so next year is going to be a key year for the company.
Absolutely.
It sounds like you're going to
Right.
really be a pivotal year. Tell me about the company management. You're the co-founder. Who else is on the board and in management at Telomere?
Okay, well, I've been around in pharmaceuticals for about 25 or 30 years. I graduated from Georgetown Medical School in DC, and I've worked at Pfizer, Merck, all the major pharmaceutical companies in the world, just about Japan, Asia, all over. And so I'm the co-founder. I discovered it with my team. I'm the CEO, president, chief medical officer. And the reason I'm doing that is because I have to make sure this works. I'm a military man. I need to make sure this works, so I have my hands on everything. Now we have staff underneath that that take care. We have clinical trials, regulatory, all different types of management. But I make sure that I'm running the top of the program, make sure this gets through the FDA so they make it to approval.
And you recently went public.
February 9th, we had an IPO, went very well.
Yeah.
We came out at $7 a share, and we floated about 1 million shares. We have like 29 million outstanding right now. And I look back at other companies, other biotechs that went public around the same time we did, and we may be 0.5 or like 1% down some of them 15 to 70% down from where they were on February 9th. So I think we're doing very well and we're very stable.
Very interesting. And you're using the money, the proceeds from that
Absolutely.
To help fund this
Yeah,
research.
we're financially we're in pretty good shape. We raised about 5.8 million. That 5.8 million will take us all the way to the phase 1 study in first part of 2025.
Okay.
So we have the funds to make it to that IND.
To get through there. Well, fascinating. I wish you the best of luck and come back next year with some updates.
I will.
On, especially these
I will.
human trials. It'll be very interesting to see what happens there.
Yes.
Thank you, Dr.
I'd be glad to. Thank you.